Thank you, Justin. Just a reminder, we're still accepting applications for lightning talks for tomorrow afternoon. You have until 8 p.m. tonight to submit any proposals that you have. Up next, we have approaches for DDoS, an ISP perspective, presented by Barry Dykes and Agi Midev.
Great, thanks, appreciate it. You can drive, go ahead. Yeah.
Great, we thought we would come up here and tell you a little bit about what we learned over the years. You'll see that on the agenda it says Barry Dykes and Agni and Mitev from Via West. Out of full disclosure, I'm no longer with Via West, but they have graciously allowed me to continue with this presentation. So we will not be speaking specifically about them, but what we've learned along the way.
Yeah, just to add, my name is Agi Mitev. I'm a principal network architect at Via West. I'm very happy to be here today to talk to you about DDoS mitigation, and we're almost there. Beer and gear is almost coming.
Beer's right around the corner.
Yeah.
So just survive this and you'll be good. One of the things we noticed as a parallel was that DDoS and the industry of DDoS kind of looked like the school system and the development of the school system. And what I mean by that is an example here. We all start with little ones. And with little ones, we get them items that they can learn stuff. They learn kinesthetic properties and stuff like that from those. So they do it all themselves, and we do it all in-house. That is really not much different than a customer who's dealing with mitigation.
Excellent. What a lot of people have done is basically deploy a device such as an intrusion detection and prevention system. It's very easy to set up. It works great for small attacks. What the IDPS box will do is we'll identify malicious activity, we'll log information, we'll make an attempt to block traffic, and we'll report. Next.
And just like the school or the home school, they realize that the little one is growing up and they don't have the resources to deal with the education that needs to take place with that little one. So what happens is they start to pool the resources. So they build this little single room shack, they get it out there. Everyone travels whatever distance it takes to get there in order to be able to educate their children or get their children educated. And the neighborhood itself is completely responsible. And this is the first step that many ISPs take in mitigating DDoS attacks. However, when you start aggregating customers, or in this case, students, you also start bringing in an element that, or an access to an element that you don't necessarily want to have there, but it kind of comes along with it. And so you find that in the modern school system, there are street gangs that they have to deal with, and they're a strain on local resources. But they're organized, and they have malintent, quite a bit like DDoS attacks. And
to deal with the disruption in a neighborhood, what many people have done is basically deploy a sinkhole controller, or also known as remote triggered black hole filtering.
And that's what you just saw just a second ago, or a minute ago, could be a few minutes ago, with what we were talking about, the last speaker. He was talking about ways to implement these black holes.
Yes, and the way that works very high level is on your sinkhole controller, you inject BGP routes with a special tag, black hole tag, that tells your router across the network to new route the traffic for the IP address under attack. To continue, as part of the sinkhole implementation, you have the capability to sinkhole or black hole IP addresses based on the source. And by taking advantage of unicast reverse path forwarding, which is available on certain platforms. The way it works is traffic comes in on the interface, And if it gets dropped, if the router doesn't have a route back to the source IP address. Next. There's a way to reroute the traffic to your sinkhole controller for an environment for additional analysis. You're basically looking at net flow, S-flow information. You can set up an interface ACL just to see if you're getting any hits on ICMP, UDP, or TCP.
So basically, you turn the whole network into this IDS type thing that shoves traffic down.
Some of the advantages of the sinkhole controller is it's basically very easy to set up. It's inexpensive. You just put a router in and talks to the rest of the network. Some of the disadvantages, you basically complete the attack. A big disadvantage is when you get a DDoS attack, you get a lot of traffic, get a lot of alarms. You start looking at net flow information to find what IP address is getting attacked. Then you go to the sinkhole controller. You actually deploy the route and gets propagated, and finally the traffic gets a black hole. And we do all this work to control collateral damage. But in case this is a very long time.
The other thing that you add to this is once the attack has been identified and you've black-holed it and you sent the community strings up to your service provider, the only way you really know whether the attack is done is to undo this and see what you get. So our happy little school system grows, and we decide that we've got to do something and we've got to make it bigger. And so that's what usually happens. At the single location, they go, we need to be able to do some type of mitigation. And so you see this, that now you have to build the transportation systems up in order to be able to get all the traffic in. You're still doing a sinkhole. It's the same thing if you're pulling it all in. Excuse me. So the transportation systems must grow. The sewage systems have to grow in that same area. So all the resources all around it have to grow in order just to support this thing.
Excellent. So we're basically talking about deploying a mitigation server or scrubbing hardware that allows you to route traffic through the box and send it to the proper destination.
But just like the single schoolhouse, you've got all the infrastructure that you have to get the traffic there and you have the traffic back. The nice thing about being a DDoS attacker, not that I'm one, but that I only have to be right once, and you have to be right every time. I just need to find the weakest link. If the weakest link is all of your transit, and I overrun that, you get to go home. It doesn't matter. All I have to do is launch the same attack. If it's the fact that your routers can't keep up with the packets per second that I'm sending, I don't care that you've got this great mitigation box. You have to upgrade everything in order to be able to deal with that. I only need to be right once.
Yeah, and what we found is basically the scrubbing center or the mitigation server works great if you put it in front of a small environment and you're only dealing with small attacks.
The pros is the mitigation server is completely in your control. That's usually a good thing. It has flexibility so you can deal with the tuning. It has self-identifying properties inside of it, which means that nobody from the outside has to have access to your network to see if an attack is occurring, because it's all done within the box itself, and that makes a lot of sense.
Okay, yeah, some of the disadvantages basically, it's very expensive. You have to keep adding more and more boxes, and there's some of the hardware that's available out there has packets per second limitations.
Also, you have to have the internal expertise. Now the DDoS is all in your hand. I don't think many of us here as service providers, our main business is understanding DDoS. I think our main business is doing other things that produce revenue and not just trying to hang on to it. So having the internal expertise and spending money here is money that we could spend somewhere else for different types of personnel who could produce more revenue than just keeping what's happening with the DDoS. The other thing is, too, is remember, this still increases our OpEx because I still have to build that infrastructure and increase it in size in order to be able to deal with all the traffic that's coming in. So this in a solution by itself just didn't get it for me. So what the school system does for this is they go to a county-style model so that each county ends up building their own school system, and they all have their own little buildings. But now the transportation system doesn't have to grow. So they do this for a cost savings benefit. However, what happens is now they have to have administrative staff, and they have to keep up with all the buildings that they're putting out there and all the different pieces. Some of these same properties that they were trying to overcome from a cost, they just moved around. And that's what you find happening with DDoS as well.
Yes, and we basically end up adding more and more of those mitigation servers across the network. And usually what happens is more hardware means more management and more personnel.
And more tools that you have to deploy in order to deal with it, those different types of things. And so the benefit to this is you've pushed it out, and now the core of your backbone doesn't necessarily have to grow because you're catching it closer to the edges. That's a good thing. It still doesn't overcome the fact that you've got to upgrade everything coming in to get to the mitigation servers, and each of those mitigation servers has to be able to deal with the amount of traffic that it could be seeing. The other thing is, often, they're not tied together, which means they're all acting independently, so the intelligence either has to be built by you or it has to be performed by you if you're that intelligent. So what do we do with our kids? We go, okay, I can't keep up with the education little Johnny needs. I'm going to send his little butt to college. And so we hope that somebody else can deal with the situation. They can scale their infrastructure, and that they can have the expertise that I need in order to educate little Johnny. So we send them off.
And much like outsourcing education, what you can do is partner with a cloud DDoS mitigation provider. The way this works is basically all the DDoS attacks come in through the provider, and clean traffic comes to your network.
You do have to deal with the GRE tunnels and all the other stuff that we were just talking about, so none of that is true.
Yeah, and basically the setup is you bring up a GRE tunnel, you establish a BGP session, and you advertise a minimum of /24 to your DDoS, cloud DDoS mitigation provider.
It'll be interesting to see what you have to do with IPv6 and what they decide on that limited amount is that you have to announce up there as well in order to pull traffic over. But basically, you pull traffic into the DDoS provider and you put it back.
Yes, and some of the concerns that come up is MTU and also the increased inbound latency. All the outbound traffic go directly to the internet.
The pros are that your mitigation service carries the growth problem. So you've got this network, and you're putting money into it. Now, if I'm growing my customer base, I'm happy to put money in my network. But if I'm spending all this money because I have some people that want to attack me once a month or something like that, I'm not really happy with that spend. I would rather put that in a new cloud. I'd rather put that into new locations. I would rather put that somewhere else where it produces something for me. So having a mitigation provider that I'm utilizing have to spend all of his resources on something that's his expertise, I'm happier with because I get to use my resources somewhere else. They also have to deal with the personnel issue, the 24/7. It's not my guys that have to be on call, it's their guys that have to be on call and keep that level of expertise. And this usually gets deployed in two different methods. One of the easiest methods is the always-on method, and it has some cons that come with it, and we'll talk about that in just a second. And the as-needed, and it has some other complications. In fact, a lot of times, cloud providers actually want some type of access to your routers, which I have never allowed. Because I thought, why do you need access to my routers? Well, because I need to do SNMP writes. I need to do SNMP read. I need your flow data some way or another. I'm not quite that comfortable. I mean, I trust people pretty much, but I don't trust them that much.
Excellent. And some of these advantages we already covered, basically the increased latency, having to go through the cloud DDoS mitigation provider, some of the MTU and PAT concerns, also the GRE performance over the internet. And one thing to note is the always-on configuration. When you route that /24 over the internet, you're kind of stuck with those IP addresses.
And what that means is that I've got a customer under attack. If it's an always-on situation, I go, I understand you're under attack, Mr. Customer. So what you need to do is switch over to these IP addresses, and you need to be able to go change your DNS. And, oh, I'm sorry, you set it for 72 hours before it changes. I'd really love to be able to help you, but I can't help you that easily. What the school system has done about these types of things is they've basically come up with a hybrid approach. And you see that with a lot of the colleges. They have the expertise at a certain location, and it's centralized. and they scale that location. But then they have satellites, and the satellites have video conferencing. Sometimes they have teachers that are there. There's different school systems that have excelled at that, and some of them that only work this way. And that's worked very well for the school system. And as we looked at that, we thought, boy, there are things that I really like about both approaches. And there's things that I don't like about both approaches. We should make a list.
Go ahead.
So one of the hardware attributes that we liked is you had control. It was local. The mitigation didn't have to necessarily go somewhere. I kind of like that. If it's not big, why send it up? Why go run to somebody else to make it happen? The other is it had the self-identifying traffic monitoring. They didn't need access to my routers. They kind of were standalone. I liked that. And that they could be integrated with my local tools because I knew what was going on. The other thing that the cloud had, though, that I really liked was I didn't carry the burden of scale just because of DDoS. The other thing I liked was they had to have the expertise. I had to have a general awareness of how things function. I just wanted some way to see it. The mitigation servers also had to maintain the equipment. I liked that. I didn't have the hardware support. They had the hardware support that they have to deal with. And of course, my transit cost didn't increase greatly just because someone may attack me in the future, so I need to quadruple what my capacity is coming in for revenue that I wasn't currently getting.
Yes, and attributes to avoid large capital investment. For a medium-sized network, we're looking at several $1 million. On top of that is the OpEx, the headcount, the additional transit capacity, and most importantly, having to deal with scaling the network.
I know your management teams may not realize this, but I think you do. When you add equipment, you kind of end up having to add people or technology, one of the two. But there's an additional spend that always comes with the equipment. It's not magic. It doesn't just happen for you. So we wanted a hybrid of both. We wanted the local. We wanted the cloud. We kind of knew what we were looking for when we started doing this. So we ended up looking around, trying to figure out what it was. I didn't like that latency thing with the cloud. So one of the things that was important to me is a provider that did Anycast. However, Anycast, if it's acting independently, is any mess. So I needed it all to pull back to a singleized database of some type so that the decision that was made was actually a holistic decision and not 4 or 5 independent decisions that occur on whether something should occur or not. The other thing is I needed them to have the flexibility of not being bound by someone else's equipment. If they were just a service and someone else's equipment, then they were kind of bound by that. So the company that I picked is I actually picked Staminus Communications because they had that type of control over their own system. They wrote their own software. They wrote their own mitigation software. So the cloud, all these other pieces, I knew that we could tie those together, and that's what we ended up doing.
Yeah, and just to expand on this drawing earlier, basically we're expanding the cloud capabilities into the network by deploying those mitigation and monitoring servers. And you mentioned the centralized database. This is only possible by allowing those monitoring mitigation servers deployed in your network to talk back to the cloud. And also, if you notice there back on the drawing, is basically talking to your Synco controller, which basically talks to the rest of the network.
The Synco controller is one of my references to that is the Spock method of DDoS management. The needs of the many outweigh the needs of the few or the one. So if the one gets attacked, you kill it. That's the Spock method for doing it. A lot of customers that are the one, they're not extremely pleased with that. So mitigation and being able to mitigate is pretty important when you start looking at this thing. However, that satellite model is really what you want, or what I wanted. I didn't want to have to deal with all that hardware. I wanted somebody else to do it. I just wanted it in my network to be able to do it. So that's one of the approaches that you may end up using. And it still uses BGP.
Yeah, and one thing to note is basically to resolve that MTU issue we talked about with the GRE tunnel earlier, is you use a carrier that provides a connection with jumbo frames. So that way you don't have to worry about fragmentation or any of that. And this is the example of how you deploy monitoring server. You have a provider, peer 1 and peer 2. They connect both to, there's a passive fiber optic taps, duplicating every packet that's coming into your network. And what the monitoring server does is basically monitors all the incoming traffic and also communicates to the cloud and to your sinkhole controller.
And along these lines, remember, this is a cost control method. If you have unlimited resources, put a mitigation box on each one of those lines. It's okay. This was just a matter of how you would go about doing this in the least expensive way that you could to be able to deal with DDoS issues.
Yes, and this is the example of deploying the mitigation server. It basically acts like an IDPS system. You have dirty traffic on one interface, then you drop the attack traffic, and the clean traffic goes out on another interface. When an attack becomes, this is probably the best part, when an attack becomes too big, we call it the swim to cloud or dance in the cloud. And what happens here is, I'll give you an example. Let's say an aggregator /net you advertise on the internet. You get an attack to an IP address. What it does, the system does, is automatically routes that /24 only through the cloud DDoS mitigation provider, which forces all the traffic to go through the cloud.
And that's set up by profiles to be able to say, if it's up to this profile, let's say it's up to 5 gigs, and you go 5 gigs for local mitigation, I'm fine with that. I can deal with that. So if it's up to 5 gigs, then that's good, and I can deal with it, don't do anything. However, if it exceeds 5 gigs, then I want you to swing it, and all that needs to be automated. What do I need to know? I need to know that something was identified and that an action was taken. And so we do that as we start to realize that we need some type of management and alerting capabilities of the profiles, of the alerts that would tell me. It could be an email, it could be an API call, it could be any of those things that says, hey, this IP address was attacked. Then you can do whatever magic you want on your end to say, well, who's the customer associated with that IP address? And I should contact them and let them know all is not good on the home front.
Yes, and what a lot of people forget is basically integration with your internal systems. I mean, it's great to partner with somebody, but everything has to work end to end. So that communication with ticketing system, alerting system, everything has to be in place. And nowadays APIs are very popular, so make sure you ask that your partner.
Yeah, you need visibility. Without visibility, you don't know whether it's really a DDoS or whether they've done the DDoS by taking out your service. So school's out for now, and I'm glad. What does everybody do after school? Get beer. So I'm sure you're happy for that. And what that means by now is education is never done. If you don't believe me, ask your significant other if you need to learn more. DDoS mitigation is at a place. This isn't the final. It will continue to grow. It will continue to change. And I'll look forward to that. Anything you want to add, Argy?
No, thank you. Any questions? We're open. I think we have like 8 minutes or 10 minutes for questions.
If you have any questions, we're glad to make something up.
Hi, Eric from Amsterdam Internet Exchange. Actually, it's not a question, but I just want to share a story on the exchange, Amsterdam Internet Exchange. So I think like one and a half years ago, a whole bunch of Dutch ISP, they come out together and they set up something like scrubbing services, and it's actually a community effort. So they set up an entity with, like, say, responsible for getting all the hardware for DDoS mitigation. They put it up, connect to the Amsterdam Internet Exchange platform, and from there, Dutch provider can use the services.
Absolutely. Absolutely. To be honest, that's nothing more than a cloud provider.
Yeah.
The cloud just happens to be there for local cross connects as opposed to over a tunnel or over a dedicated circuit. The difference we're talking about are two things. The length of the tunnel, I assume they have somebody running that, and that everybody doesn't have independent run of it, which means that basically it is its own DDoS provider. Absolutely. Makes tons of sense. It's the same thing they did with the school system by pulling all the resources and going, we need to send our kids somewhere together.
Yeah, because at Amsterdam we already have the platform of Amsterdam Internet Exchange over there. So just like put up the services, everybody can connect to it, and it grow by demand. So if more members come in, they have more resources and to like buying upgrade hardware, buying more powerful boxes for DDoS mitigation. So personally, I think it's a good example of community effort for that.
Yep, it's always only money.
Exactly.
Yeah, this is a great comment. I was going to say that some organizations that have the volume or the scale, that's what they've done. They've actually come up with their own scrubbing centers. They just buy a bunch of 10 gig circuits and put the hardware in. And the beauty about that setup is that actually it's very easy to make it work with your internal mitigation services. Basically, having that communication is very important so that you can swing the traffic again in case it's too big.
Well, the other thing that's really nice by doing that by cross-connect is there is no GRE tunnels, therefore there are no MTU issues to deal with. Basically, it's cross-connects, and that's nice if it's facilitated with you. Yep.
We still don't have jumbo frame on the platform yet, so.
Yes, I'm making an assumption.
All right.
Okay. Well, thanks, guys. Appreciate it.
Thank you very much.